another simple algebraic equation to see if it's a function. Y equals x plus 1. Again, the x values will be inputs, the domain, and the y values will be the outputs, the range. Let's quickly generate a function table for a few possible input values, like the integers -3 through +3. If you watched our last video about graphing on the coordinate plane, you may notice that each row of this function table is basically just an ordered pair. It's an x value followed by a y value. We could even rewrite all the inputs and outputs in ordered pair form if we wanted to. And that means you can also graph all of these pairs of inputs and outputs on the coordinate plane. You can graph a function. Here are the points from our function table plotted on the coordinate plane. And here's the resulting graph we get if we connect those points. It forms a straight line, and it's an example of what is called a linear function. In algebra, there are lots of different kinds of functions that have interesting graphs. Quadratic functions, cubic functions, trig functions, and many more. These graphs may look like just a bunch of squiggly lines, but they're all functions. And we can tell they're functions just by looking at their graphs because they all pass the vertical line test. Remember how functions aren't allowed to have more than one output value for a particular input value? Well, the vertical line test helps us see if a graph has any of those one-to-many relations that would disqualify it as a function. Here's how it works. Imagine that a vertical line is drawn on the same coordinate plane as the graph that you want to test. Then, imagine moving that vertical line left and right across the domain, paying close attention to the point where the vertical line intersects with the graph. If that vertical line only intersects the graph at exactly one point for every possible value of x in the domain, then that means that there's only one output value for each input value. There's only one y value for each x value, so the graph qualifies as a function. Okay, so all of these graphs pass the vertical line test and are functions. But what's an example of a graph that doesn't pass the vertical line test? Well, here's one. It's the graph of our equation y squared equals x. The domain of this equation doesn't include any negative input values, so there's some places where a vertical line wouldn't intersect the graph at all, and that's okay. And there's one place where the vertical line would intersect the graph at just one point, which is also okay. But as we move to the right on the x-axis, you can see that our vertical line is now intersecting the curve in two places. That means this equation is giving us two possible outputs for some of its inputs, which means that it's not considered a function. Okay, now before we wrap up, we need